उसमें मैथ्स में 60 नंबर थे मेरे फिजिक्स में। ठीक है, बकवास नहीं करनी।
फालतू है लोग।
We need value of del v और del y। अब इसी
Good morning, sir.
Good morning, everyone.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Morning, sir.
Good morning, sir.
Good morning, sir.
Morning, sir.
Morning, sir.
Good morning.
Good morning, sir.
Good morning, sir.
Good morning, sir.
Good morning, sir.
So, students, we'll start the course of applied physics. I hope my screen is visible to everyone.
Yes, sir.
Yes, sir.
Yes, sir.
Yes,
And
sir.
before that, I was taking the classes of another group which has already taken the admission, I think 2-3 months back. So I have already covered half of their syllabus. Okay, so I think this syllabus is visible to everyone. So it has 4 units: oscillations and waves, and acoustic and ultrasonic. This is a part of 1 unit. Second unit is electromagnetic wave. Okay, and fourth unit is optics, which contains interference, diffraction, polarization, and laser. And fourth unit is quantum mechanics. So I think you are used to with these, or you have known the topics of first 3 units up to optics. So and since we have started the late, I think half of the semester we are late. So if you allow me to take some fast few lectures, then we'll be able to cope up the gap because of late admission. ठीक है बच्चे? So अगर आप disturbance create नहीं करोगे तो आप हमारा syllabus जो है that will be covered in time. ठीक है? So this is group 1, subgroup 1, 2, 3, and 4. This is class for subgroup 1, 2, and 3, and 4.
Yes,
All right. Because some students are asking in the chat group whether this is group 2 or group 1. So I think new admission group has 7 subgroups. First 4 subgroups are in this class, and the subsequent 3 subgroups, they are taking the simultaneous class of Professor Chandni. Okay.
So this is the practical class, right?
This is theory class, Vijay.
Okay, sir.
So this is your lecture class. All right. So shall we start?
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
So
So what is your good name?
my name is Dr. Rajkumar. From School of Physics and Material Science. ठीक है बच्चे? So to begin with, we have oscillations and waves. So I'll try to cover each and every aspect of this unit. So to begin with, what is oscillations? Any idea?
Disturbance in medium.
Disturbance in any kind of medium. ठीक है?
To and fro motion, periodic
To and-
motion.
Periodic motion, to and fro motion. And one more thing, I am recording this lecture, and this recorded lecture will be available to you on LMS website. So do not worry about how to record this lecture or permission for recording the lecture. I am already recording that lecture. Okay, students?
Excuse me, sir.
Sir, where to find the PPT for the same?
It is available on LMS website. Everything regarding this course is available on that website.
Fine.
Do we need to make notes like while class is going on?
You can make the notes, no issue.
Okay.
So waves set up the medium of their propagation in oscillation. ठीक है जी? So wave जिस भी medium से travel कर रही है, चाहे वो liquid हो, air हो, या solid हो, it will force the medium to oscillate. In ideal conditions, oscillation continue with same amplitude. If there is no drag, no resistance, no negative force, no damping, then there will be no decay of amplitude. Like this wave is showing on the slide. ठीक है जी?
Excuse me, sir.
हाँ जी.
Sir, what is damping?
Let me start the unit first, बच्चे.
Okay,
Damping
sir.
is in between. And
Okay.
one more thing, please. If you keep on interrupting me like this, then our syllabus will not be completed in time. So let me complete the topic. Then I will ask you about the questions, and I will answer all your questions. Okay? I hope you understand.
Yes, sir.
Yes, sir.
So this is a kind of wave, sine wave or any wave you see, and you see amplitude. This is the amplitude. It remains same throughout the cycle. This is a naught, for example, and your wave is x is equal to a naught sine omega t, for example. ठीक है? So
Sir, this is cos 1.
but I am saying any wave. If you're,
Yes, sir.
you can also choose this one. Whether
Yes,
you have to choose cos function or sine function, it depends on the initial condition, the initial boundary condition. Okay, whether the particle has mean position or at extreme position. So in reality, no medium exists without any negative force, dissipative force, or damping force. It is that force due to which your amplitude decreases. Okay? For example, if your car is moving at a speed of 60 miles per hour, and if there is no damping force, there is no air drag, it will keep on moving. And Newton's law according Newton's second law, it will keep on moving with the same speed. But due to air drag, after some time, gradually with time, your speed decreases. If you remove the force from the accelerator, your amplitude will decrease, speed will decrease. So this is due to negative force. So we have to consider a particular category of these oscillations, that is simple harmonic motion. So a body undergoes motion when acted upon by force. The force can be constant or varying. Constant है तो obviously it is moving, the particle is moving in a straight line like this. And if force is varying, how can you find the force? Just by dividing with the mass. You can find the acceleration just by dividing the force with the mass. ठीक है जी?
Yes, sir.
So, अच्छा, what is the difference between a simple harmonic motion or a periodic motion?
Sir, simple harmonic motion, the equation is equal to minus omega.
Sir, force is proportional to the power 1 of displacement from the mean.
For example,
In SHM.
if I ask you whether the clock on a wall is doing a periodic motion, yes or no?
Yes, sir.
Yes, sir.
So, and second question, and since it is a periodic motion, whether it performs the oscillation as well,
No, sir.
No, ma'am.
Yes.
No, sir.
No,
No, sir.
sir.
No, sir.
No, sir.
Yes.
And
Yes.
if a clock has a pendulum, so then next question is whether pendulum is performing the oscillations.
Yes, sir.
Yes, sir.
Yes,
Yes,
sir.
sir.
Yes, sir.
So any motion which has mean position, yeah, and force is proportional to displacement with the negative sign, that is called simple harmonic motion. ठीक है जी. और periodic क्या है? That repeats its cycle after a given time, but it is not always necessary कि वो particular mean position पे वापस आए. For example, this is the case. This is the wave. It repeats after this time t. ठीक है? अगर यहाँ से start होता है, so it repeats after every time t. But it is not coming again and again at this central point, origin. It is moving in forward direction. So though it is periodic, but it is not oscillation. It is not oscillatory in nature.
Sir, I have a
nature.
doubt.
हाँ, student.
Sir, in this damped oscillation, it is that the amplitude is decreasing. Sir, is it still periodic?
Yes.
Damped oscillation as well.
Yes.
Okay.
So we'll cover that in the next unit, next topic. So
Okay, sir. Thank you.
so अभी हमने क्या डिस्कस किया मुझे कि periodic क्या है, oscillation क्या है, then simple harmonic motion क्या है. Simple harmonic motion में वो motion आएगी, that category of motion in which force is proportional to the displacement. ठीक है. So इस यूनिट में हम क्या करेंगे विजय? Simple harmonic motion हमारे पास जो है long answer type article में simple harmonic motion, in that we will also consider the spring oscillations, mathematical derivations, energy in case of simple harmonic motion, period and sinusoidal nature of SHM. Then we'll consider simple pendulum, okay, damped oscillation and forced oscillation. And in case of SHM and damped oscillations, we'll also consider their electrical analog. LC circuit is electrical analog of SHM, and LCR circuit is electrical analog of damped SHM. Okay? So this is the overview which we'll cover in this subtopic. Okay? So further, I'm repeating, a special type of motion called periodic motion. It is a repeating motion of an object in which object continues to return to given position of a fixed interval of time. For example, periodic motion में pendulum भी आएगा, beach ball floating on the waves up and down, ठीक है, back and forth movements of objects called oscillations. So these are few examples of periodic motion. We'll simply focus on periodic motion, which is simple harmonic in nature. अच्छा, why we are interested in simple harmonic motion? What is so great about this kind of oscillation? So the thing
It's the
is,
most basic.
yeah, obviously it is the most basic category of oscillations. So we shall find that all the periodic motions can be modeled as combination of simple harmonic motions. So different frequency and different oscillation की simple harmonic motion को अगर हम overlap कर दें, add कर दें, so हमारे पास वो particular periodic motion आ जाएगी. So if we know the solution of simple harmonic motion, we can easily solve the other complex problems which involve directly or indirectly the simple harmonic motions. So that is why we are interested in solution of simple harmonic motion, or we are interested in knowing how energy is varying in simple harmonic motion, how their amplitude is varying, and these kinds of things. So simple harmonic motion forms a basic building block for more complicated periodic problem. Okay? So simple harmonic motion also forms the basis of our understanding of mechanical waves. So mechanical wave may be so in any place we can apply simple harmonic motion solution. For example, sound wave, seismic wave, and wave on stretch string. So we can apply our knowledge which we'll gain by studying the simple harmonic motion in the complex problem as well. Then sound wave travel through air. Elements of air oscillate back and forth as a water wave travel across a pond. So these are few examples which are given, which involve simple harmonic motion directly or indirectly. Okay? So to explain many phenomena, naturally occurring phenomena, we must understand the concept of oscillation and waves. So this is the motivation behind studying this unit. Okay? Then we have a combination of simple harmonic motion. We have a combination of spring and mass, M. So spring oscillation. So this is the mean position. X is equal to 0. A mass is placed and attached with the spring on a horizontal bed, and the next corner is fixed. The spring mass is fixed at this point. So if a object vibrate or oscillate back and forth over a same path, so इस horizontal bed के along ही ये इस तरफ या इस तरफ oscillate करेगा. Each cycle taking same amount of time. The motion is called periodic. So अगर आपका जो cycle है वो repeat कर रहा है fixed time के बाद, that is called periodic motion. ठीक है जी. The mass and spring system is a useful model for a periodic system. So आपका ये जो basic understanding के लिए आपका ये जो spring and mass का combination है, it is the basic. So ये x is equal to 0 mean position है. ये left की तरफ भी जा सकता है, right की तरफ भी जा सकता है. So when it stretches towards the right side, so हम इसको origin x is equal to 0 मान लें, तो इस तरफ अगर हम positive मान लें, so this is the maximum amplitude which it can go. अगर यहाँ से हम इसको leave करते हैं, so there is a force in negative direction. Arrow is in opposite direction. So ये mean position से इस तरफ इसको ले आएगा. ठीक है जी. So this is the minus a position of this mass. ठीक है. And this is the x is equal to 0 mean position or equilibrium position. So this spring अगर उसके साथ कोई mass attached है, if we apply a force in opposite direction and leave it, it will start performing the simple harmonic motion to and fro. So अगर हम इसको plot करने की कोशिश करें यहाँ से बच्चे देखो, so like this. ठीक है. So it is a wave nature. So half sine cycle हमें मिल गई इसमें. ठीक है जी. अब ये actual जो है x is equal to minus a, x is equal to 0 और x is equal to plus a. So different possibilities are there. So mean position से इस तरफ गया, तो x is equal to minus a position. The particle, whether it is at minus a or plus a amplitude, that is at two extreme points, velocity is 0. So ठीक है, velocity 0 होगी तभी ये वापस opposite direction में आएगा, otherwise तो fly off हो जाएगा. Similarly, equilibrium position पे क्या होगा बच्चे? Velocity will be maximum at equilibrium position. Force is 0, velocity will be maximum. और अगर plus a की तरफ जा रहा है, तो यहाँ again at extreme position, velocity is 0 and it is moving backwards. So acceleration is in negative direction, and this process continues. So displacement is a measure from equilibrium point. So this is important as far as numerical point of view is concerned, that we'll always measure displacement from equilibrium point. So this is the equilibrium point. Amplitude is the maximum displacement. So maximum displacement क्या है? Either on left side or right side, it is plus minus a. In magnitude is a. So a cycle is a full to and fro motion. This figure shows half cycle. So अगर मैं यहाँ से एक wave draw कर दूं इसकी position से, so it is kind of showing half cycle. And period is time required to complete one full cycle. And frequency is number of cycles completed in 1 second. So this is the prerequisite knowledge for studying simple harmonic motion. Students, please do not make noise. Mute yourself.
Sir, please mute Natik.
Sorry, sir.
So then there are few assumptions which we'll make while deriving the equation for simple harmonic motion. What are those assumptions? We assume that surface is frictionless. First thing, what is meant by frictionless? That is, there is no damping force. Though we know that in nature there is no system exists which does not have a damped nature, but we are considering the ideal nature here. So there is no friction, first one. And there is a point where spring is neither stretched nor compressed. So एक ऐसा point होगा जब spring पे कोई force नहीं होगी, that is called equilibrium position. ठीक है? And we measure displacement from x is equal to 0 point. So these are the prerequisite assumptions for deriving the simple harmonic motion. Now the force exerted by spring depends on displacement. So मैं सीधा लिख देता हूँ. So your f is proportional to x, and when we remove proportionality sign, it becomes minus kx. Minus is, it is in opposite direction. ठीक है जी. So minus sign on the force indicates that it is a restoring force, and it is directed to restore the mass to equilibrium position. ठीक है. K is spring constant, the spring which we used in the spring mass system. ठीक है जी. So यहां से हम इसको सीधा सॉल्व कर सकते हैं. F को हम यूजिंग न्यूटन सेकंड लॉ मास इनटू एक्सीलरेशन लिख सकते हैं, माइनस के एक्स. ठीक है. इस इक्वेशन को मैं रीराइट कर देता हूं, माइनस के बाय एम एक्स. फर्दर आई कैन रीराइट एक्सीलरेशन इन टर्म्स ऑफ डिस्प्लेसमेंट डी स्क्वायर एक्स बाय डी टी स्क्वायर, और इस तरफ इसको ले आता हूं के बाय एम एक्स इज इक्वल टू 0. इफ आई सब्स्टिट्यूट दिस इज इक्वल टू ओमेगा नॉट स्क्वायर, the natural frequency of oscillation. I have kept intentionally this 0 here because it is used as notation for natural frequency of the system. Okay, when there is damping force, we will simply write omega. So it is d square x by dt square plus omega naught square x is equal to 0. Different books use different notations. Okay, so this is your equation for simple harmonic motion. ठीक है, वेयर एंगुलर फ्रीक्वेंसी आपकी क्या होगी, k बाय m स्क्वायर रूट. ठीक है जी. सो दिस इज द सिंपल हार्मोनिक मोशन एंड एंगुलर फ्रीक्वेंसी.
Sir, what does omega naught denote?
Natural frequency of oscillation. When there is no damping force or no negative force, so in order to differentiate, you can use omega as well, no issue. Just you have to mention that omega.
Angular frequency and angular velocity same or different?
It is different.
So, but the symbol is same for both. So
Where
what
is the symbol?
difference? I don't understand. So the angular frequency is omega only, and angular velocity is also represented as omega.
You are mixing the two systems, but this is the case of spring mass, and you are mixing it with the simple pendulum case.
So in simple pendulum, it is the angular velocity.
Velocity.
Okay.
So this we have already written. Okay. So we have came up to this point. This is the simple harmonic motion, and omega is the angular.
And root k.
Excuse me, sir.
हाँ जी बच्चे.
Sir, if we compare SHM to circular motion, uniform circular motion, then omega is the same thing, like the angular velocity.
Yes,
so
yes,
in
yes.
that way, both symbols denote the same thing. Answering this question.
Yes.
Excuse me, sir.
हाँ जी बच्चे.
Sir, what is damping?
What is your name, student?
Anish, sir.
What is your name? Anish?
Yes,
But
sir.
Damping is when you are giving a same amplitude. For example, this is your wave moving sinusoidally, है ना? In air, in vacuum. So this is a fixed amplitude A naught. But if air drag is there, okay, so what will happen when damping force is there? So your initial amplitude is like this, and it will keep on decreasing like this. So your amplitude is exponentially decreasing as compared to no damping case. So damping decreases the amplitude. Negative force है ना, friction, like frictional forces. ठीक है. So
so can you please tell what omega naught was? I just forgot.
This is a natural frequency of oscillation.
Okay. Okay. Thank you.
ठीक है. So अब बच्चे अगर ये इक्वेशन है मेरी, ये वाली, ये इक्वेशन किस तरह का सॉल्यूशन सेटिस्फाई होगा इसको? आपके पास इक्वेशन है डी स्क्वायर एक्स बाय डी टी स्क्वायर प्लस ओमेगा, ओमेगा नॉट लिखना है या ओमेगा स्क्वायर लिखना है आपके. So what is the possible solution for this kind of equation? It is the differential equation which involves second order derivative as well as the function itself as. So x भी है और x का 2 बार डेरिवेटिव भी है. So कौन सा फंक्शन है जो 2 बार डेरिवेटिव लेने पे अपनी वैल्यू रिप्रोड्यूस कर लेता है?
Exponential function.
No, exponential is also there. Also sine and cosine function are also there. ठीक है जी. So अच्छा, अब साइन को फंक्शन इसमें डालेंगे वो भी इसको सेटिस्फाई करेगा, कोसाइन फंक्शन डालेंगे वो भी इसको सेटिस्फाई करेगा. सो विच वन टू टेक?
So it depends
So
कि
it will
आपने
depend upon the
displacement क्या लिया था.
displacement हाँ कैसी लिया आपने.
So we have
starting from the mean position you'll take sine. If
And in
you're starting
extreme
from the
cos.
maximum position you'll take.
So like this. So at origin, if at t is equal to 0 your amplitude is 0, it means you are following the sine function, so you have to take the solution as sine. And if at t is equal to 0 you have maximum amplitude a0, it means you have to take cosine function. So it depends on your
sir, the phase difference should be 0.
Phase difference also there. ठीक है जी. So we assume that x is equal to a cos omega t plus phi, where phi is the initial phase. ठीक है. So this kind of solution will satisfy this second order differential equation, simple equation. A, omega and phi are constant in this case. ठीक है. So this is the example of displacement. If we attach a pen to a spring and move a horizontal paper, vertical paper, then it will start performing like a sine wave, like this. Sinusoidal wave. Okay? Like this. So this is the nothing but the animation. I think this is not working in animation here. So it represent whenever you attach a mass with a spring, it will follow sine function or cosine function with periodic in nature. So time period क्या होगा बच्चे इसमें? Time period is 2 pi m by k. It is related with the frequency. It is 2 pi by t or simply 2 pi into nu. So यहाँ से t की वैल्यू आप निकाल सकते हो. T is 2 pi by omega. ओमेगा की वैल्यू हमने सब्स्टिट्यूट कर दी k by m square root डिनोमिनेटर में. So it will become t is equal to 2 pi m by k. So this is the period of the simple harmonic motion. And corresponding frequency is 1 by t. So आप यहाँ से ये निकाल सकते हो easily. ठीक है जी. So this is the time period and frequency of oscillation. Then we'll plot these different functions. So we have assumed that x is a cos omega t plus phi.
Can you show the previous slide once?
Okay.
Okay, sir.
So I have just plotted the function. X is a cosine function with a fixed amplitude. So if I say this one is fixed amplitude. So since it is a cosine function, so I assume that this is t is equal to 0. This point is t is equal to 0. So it starts from maximum amplitude here. And velocity is first order derivative of displacement. So dx by dt, it is minus omega a sine omega t plus phi. Its amplitude is omega times a in opposite direction as compared to the displacement. So at t is equal to 0, we have this point. Since it is sine function, so velocity should be 0 at t is equal to 0. So it is 0. And as amplitude is in positive direction, it is in negative direction, like this. Further, acceleration is second order derivative with respect to time. So it is omega square amplitude with the negative sign, okay, varying as a cosine function. So cosine means it is having at t is equal to 0, it should have maximum value, either positive side or negative side. And since negative sign is there, so this is the maximum value at opposite direction. So this acceleration is varying like this. Okay? And maximum value of velocity v max. So इसका maximum, इस function का maximum कब होगा? When sine omega t plus phi is maximum, because omega into a is constant. So sine omega t plus phi has maximum value of 1. So in magnitude, velocity will be maximum when v max is equal to omega times a. Omega की value है k by m square root into a. Simple. Similarly, acceleration will be maximum when cos of omega t plus phi will be maximum in magnitude. So maximum value of cos is equal to 1 again. So acceleration maximum will be equal to omega square into a in magnitude, and omega square की value है k by m into a. So simply we have maximum value of velocity and acceleration. And remember that maximum velocity will be at equilibrium position and maximum acceleration will be at extreme position. ठीक है जी? Now we'll summarize what we have done. We started with the F is equal to minus K equation. We have reduced from first equation to the differential equation, and we found that solution is of this type, equation number 3. Okay? And its wave behavior is, it varies like this function. Time period we get is 2 pi square root m by q. Corresponding frequency is 1 by t. So we can easily find the frequency as well. Now let us move on to the case of simple pendulum. A simple pendulum consists of a mass at the end of lightweight cord. So this is our cord. Okay, and this one is the mass. Okay, we assume that cord does not stretch, so there is no elasticity of this thread, for example, and its mass is negligible, so there is no mass, so it is not contributing to the this mg, or it is not having the elasticity, so there is no stretching or other thing like that. If the cord have mass, then this problem will be difficult. Okay, then we have to consider all the forces, because you see here F is equal to ma. So this is the Newton's law. If you know each and every force acting on the body, then you can apply F is equal to ma. If you do not know all the forces, then your Newton's law will not be applicable. So if this cord has weight or it has elasticity, you have to consider that points as well while writing the Newton's law. So that is the thing. So for simplicity, like we have assumed that while performing the simple harmonic motion, that medium is frictionless. So this is the basic assumption.
So
Hanji.
In this case, maximum acceleration will be g sine theta.
Yes.
Okay, so thank you.
So this is the simple graphical representation. At any time, we have this mass at this point. Okay, tension is in opposite direction in this string, and we have mass due to weight, force due to weight, mg. In component, we have mg cos theta here and mg sin theta here, if theta is this angle. Okay. Now let us write the equation in order to be simple harmonic motion, the restoring force must be proportional to negative of displacement. ठीक है जी? So ये जो आप पूछ रहे थे g sin theta, here it comes. So F should be equal to minus mg sin theta. ठीक है जी? So F is equal to minus mg sin theta. Further I write m Newton's second law.
सर ये मेन पोजीशन की तरफ से निकाला ना कि मेन पोजीशन में कितना नेट फोर्स लगेगा.
हाँ जी बिल्कुल. So it is m into d square s by dt square. S क्या है? S is this much distance. ठीक है जी? So mean point से ये जो mean point है आपका theta is equal to 0 के corresponding, इससे ये कितनी दूर गया? So S क्या होगा बच्चे? If the length of this chord is L, this is angle theta, and this is S. So S क्या होगा? In terms of L and theta.
L theta. L sin theta.
L theta.
If theta is small, then L theta.
Yeah, obviously. So it is small angle. We are not doing a wild periodic motion. So this is the simple. If this is S, this is L, this is theta, then S is equal to L theta when theta is small. So S is equal to L theta. When we substitute this value of S here, we'll simply get this equation: d square theta by dt square is equal to minus g by L sin theta. Simple. ठीक है जी? And again, following the same steps.
Previous slide दिखा दो.
But remember that you are applying Newton's second law while deriving this equation, and we are assuming the simplest case: no weight of the cord, no elasticity, no stretching of the cord. And if you are to consider all these components, you have to apply Newton's second law accordingly while considering all the forces.
So can you tell how did the last equation came one more time?
This one?
D square theta by dt square.
So simply you substitute value of S. So it is m d square s by dt square is equal to m d square L into theta by dt square. L is constant, it will come out m into L d square theta by dt square. ठीक है, और यहाँ पे आपके पास ये है बराबर माइनस एम जी साइन थीटा के. ठीक है, सो m से m कैंसिल हो जाएगा यहाँ पे. ठीक है जी, सो आपके पास इस इक्वेशन में आ जाएगा व्हेन वी डिवाइड बोथ साइड बाय कैपिटल L. तो यहाँ पे g बाय L हो जाएगा. ठीक है, ये उस तरफ जाएगा. सो d स्क्वायर थीटा बाय dt dt स्क्वायर. ठीक है जी. फर्दर अगर एंगल स्मॉल है वी कैन इजीली राइट साइन थीटा अप्रोक्सीमेटली इक्वल टू थीटा. ठीक है जी, तो वही हमने यहाँ पे लिख दिया है. सो d स्क्वायर थीटा बाय dt स्क्वायर इज इक्वल टू माइनस g बाय L थीटा. ठीक है जी, एंड if we substitute omega is equal to g by L square root, so we'll get the same equation as that of simple harmonic mechanical simple harmonic motion, but the difference is that here variable is angle. ठीक है जी, so x की जगह आपके पास theta है. Rest of the equation is same, so we'll get the same time t is equal to 2 pi by omega. ओमेगा की वैल्यू हमने 2 पाई g by L स्क्वायर रूट पुट की है. ठीक है जी, और कॉरस्पॉन्डिंग हमने देखा मैकेनिकल के केस में हमारे पास था टाइम 2 पाई m बाय k. सो यहां हमारे पास पेंडुलम के केस में 2 पाई L बाय g. ठीक है, सो इंस्टेड ऑफ मास वी हैव लेंथ हियर एंड इंस्टेड ऑफ स्प्रिंग कांस्टेंट वी हैव ग्रेविटेशन g. ठीक है, और इक्वेशन में हमारे पास x को हमने रिप्लेस कर दिया थीटा के साथ. यहां तक क्लियर है बच्चे? कोई डाउट है तो पूछ सकते हो.
No, sir.
So then we have started with the simple harmonic motion. We have made the assumptions, we have derived their equation, then we assume that this kind of equation has this particular type of solution. Then we derived the time period, frequency, okay, all that. Now we have to discuss about the energy of simple harmonic motion, energy associated with that system. So in an ideal system with no non-conservative forces.
Sir, I have a doubt.
हाँ जी बेटे.
Not about this physics stuff, but sir, in the SHM equation, the differential equation, we had 2 degree this differential equation. So, sir, we have not been taught how to do it. So, will we be taught in maths about this?
Yes, yes, you will be given details in mathematics class how to solve a ordinary differential equation.
Okay.
ठीक है. What we have done is we have this method is called hit and trial method as well. So we have assumed a particular, that is why I've asked you what kind of what form of solution, what kind of function will satisfy that particular equation, because that involved the displacement as well as second order of displacement. So the function which satisfies this type of equation, since we have to simplify that equation, so we assume that it is sine or cosine. ठीक है, and with the unknown amplitude capital A, so we don't know about the amplitude. So by applying the boundary conditions we can get the exact solution.
So but if in the paper it comes like
you can write simply directly, there is no need of solution.
Okay sir, thank
ठीक है
सर.
हाँ जी बेटा.
सर SHM का सर जो वो ग्राफ था सर, उसमें जरूरी है कि सर t is equal to 0 पे मतलब कि मिनिमम में मैक्सिमम पे ही होगा, मतलब कि किसी बीच फेज डिफरेंस पे तो हो सकता है बीच में कहीं पे, जैसे cos omega t plus phi था अगर t 0.
हाँ, but if there is phase, because we are dealing with the simplest cases, so if there is phase then it can change.
तो सर तब तो हम डिसाइड नहीं कर सकते ना ऐसे कि ये देख के कि t is equal to 0 पे कहाँ है कि हम cos की वेव लें या sin की वेव लें, तब तो हम कुछ भी ले सकते हैं ना.
हाँ, तब आप cos भी ले सकते हो, हाँ cos भी ले सकते हो, sin भी ले सकते हो, and you can also take the linear combination of cos and sin as well.
तो सर पूरा डिराइव करना पड़ेगा ना कि आपने डिस्प्लेसमेंट टाइम कैसे कैसे लिया हुआ है फिर.
बच्चे सिंस वी आर कंसीडरिंग द सिंपलेस्ट केसेस.
नहीं सर मैं उसका कह रहा हूँ तो
हाँ, उस केस में आपको डिराइव करना पड़ेगा.
हाँ.
So let us move on to again the energy conservation in oscillatory motion. So in ideal system no non-conservative forces, so velocity and acceleration dependent forces नहीं है हमारे पास. So we know simply we have total energy E is equal to K is kinetic energy and U is potential energy. So kinetic energy कितनी होगी बच्चे स्प्रिंग मास कॉम्बिनेशन की अगर हम बात करें
half
kx
m
square.
omega
half
square.
mv
half
square.
mv square and potential energy is half kx square.
Half kx square.
So you know about the detail of half kx square or should I explain it?
No, so we already know.
Okay, so work done. It is work done in moving the body from x to x plus dx. So इस point पे body है अगर x पे इसको x plus dx पे लेके जाना है तो small work done होगा dw is f dx. So if you substitute the value in magnitude kx dx और अगर हम integrate करते हैं both sides, so we'll get work done is half kx square, which is stored in the system as potential energy. ठीक है जी?
Okay.
So simply written, potential energy is half kx square, kinetic energy is half mv square. So आपके according, if energy is conserved, their sum is also conserved. क्या kinetic energy और potential energy भी conserved है मुझे?
No,
is
sir.
it possible?
No.
Since it is known that only total energy is conserved, kinetic energy can change in magnitude and potential energy can also change in magnitude, but sum of kinetic and potential energy should be always constant if the system is non-conservative in nature, not non-conservative in nature. So total energy मैंने लिख दिया half mv square plus half kx square. ठीक है, अब हम देखते हैं कि डिफरेंट सिनेरियो इक्विलिब्रियम पोजीशन या एक्सट्रीम पोजीशन हमारे पास हो तो क्या होगा. सो एक्सट्रीम पोजीशन फॉर एग्जांपल x इज इक्वल टू माइनस a या x इज इक्वल टू प्लस a, वेलोसिटी क्या होती है इस पे?
सर मैक्सिमम जीरो
मैक्सिमम होगी तो बॉडी विल कीप ऑन मूविंग इन दिस डायरेक्शन, बट आई एम सेइंग इट इज द एक्सट्रीम पोजीशन, सो इट मींस वेलोसिटी इज जीरो, एक्सेलरेशन विल बी मैक्सिमम बट इन ऑपोजिट डायरेक्शन. सो वेलोसिटी जीरो हो गई तो आपके पास काइनेटिक एनर्जी जीरो हो गई. ठीक है, काइनेटिक एनर्जी जीरो होते ही और आपके पास x इज इक्वल टू माइनस ए है यहाँ पे. सो काइनेटिक एनर्जी पोटेंशियल एनर्जी क्या हो जाएगी? पोटेंशियल एनर्जी इज हाफ के एक्स स्क्वायर. ठीक है, और x इज इक्वल टू माइनस ए है तो इट विल बिकम हाफ के ए स्क्वायर. सो टोटल एनर्जी, और यही आपकी टोटल एनर्जी होगी, है ना? E
इस स्लाइड में वो माइनस के एक्स स्क्वायर नहीं होगा,
बट बच्चे मैग्नीट्यूड है वो, हम सिर्फ मैग्नीट्यूड की बात कर रहे हैं.
पोटेंशियल एनर्जी इज अ स्केलर क्वांटिटी.
सर तो एक्सट्रीम पोजीशन पे टोटल एनर्जी पोटेंशियल एनर्जी के बराबर आ जाएगी.
हाँ, so that is why I am saying now your total energy is only potential energy. So extreme point पे चाहे minus a पे हो चाहे plus a पे हो, you will get only potential energy. There is no kinetic energy because body needs to come at rest at extreme position. तभी वो अपनी direction reverse करेगी ना. अगर वो एक mean position पे rest पे आएगी नहीं तो वापस कैसे आएगी? It will keep on flowing. ठीक है, और moving in that particular direction. Now let us consider the second case, है ना? At x is equal to 0. x is equal to 0 पे हमारे पास जो टोटल एनर्जी थी हाफ mv स्क्वायर प्लस हाफ kx स्क्वायर. सो x is equal to 0, इक्विलिब्रियम पोजीशन, पोटेंशियल एनर्जी तो 0 हो गई. ठीक है, और वी नो दैट मैक्सिमम वेलोसिटी होगी इस पॉइंट पे x is equal to 0 पे. सो आपके पास काइनेटिक एनर्जी हो जाएगी हाफ mv मैक्स स्क्वायर. सो टोटल एनर्जी सिर्फ kinetic energy हो जाएगी. So at equilibrium position or at mean position, you will only have the kinetic energy. There is no potential energy at this point. ठीक है, और अगर आप फर्दर राइट साइड पे x is equal to plus a पे चले गए, there again velocity will be 0 and there is only potential energy in the system. There is no kinetic energy. So you see that kinetic energy at extreme position, potential energy is there and it is shifting to kinetic energy while moving to the equilibrium position and total energy becomes only the kinetic part at x is equal to 0 and it further exchanging between potential and kinetic energy. So total तो दोनों का sum, for example आपके पास है E is equal to kinetic energy plus potential energy. So अगर मैं कह देता हूं कि ये 8 है और ये 2 है for example. So 8 plus 2 is always 10. ठीक है जी. सो हो सकता ये दोनों का सम है 10. सो इस पॉइंट पे 10 होगा. ठीक है, दैट इज ओनली पोटेंशियल एनर्जी. इस पॉइंट पे भी 10 होगा बट ओनली काइनेटिक एनर्जी, और इस पॉइंट पे भी 10 होगा एनर्जी, टोटल एनर्जी, बट ओनली पोटेंशियल एनर्जी। सो यहाँ इस ग्राफ से भी क्लियर है बच्चे, ये जो मैंने बार ग्राफ यहाँ पे डाल रखा है। सो एट एक्सट्रीम पॉइंट देयर इज ओनली पोटेंशियल एनर्जी, देयर इज नो काइनेटिक एनर्जी। At equilibrium position, there is only kinetic part. There is no potential energy. Further, at extreme point on right hand side, there is only potential energy, but no kinetic energy. And in between, at any random x, we have some bit of potential energy as well as kinetic energy, such that their sum should be constant, which is equal to total energy. So this is how energy is conserved inside a simple harmonic motion.
Excuse me, sir.
Anji.
Sir, I think that it is not important that the potential energy should be zero at the mean position. Like the potential energy due to the stretch is zero, but the spring can have a potential energy by virtue as well.
Yes, sir.
But you forgot the first assumption that
Spring is massless.
yeah, we assume that spring is massless, and at x is equal to 0, there is neither stretching or compression inside the spring. Okay, so we have made the things simpler in order to derive. So complexity को avoid करने के लिए हमने कुछ assumption डाल दी थी उसमें, ठीक है जी। So अब हम देखते हैं बच्चे k max kinetic energy maximum which is equal to half m a square omega square, ये होगा half mv square ना। So आप v max की वैल्यू जब डालोगे तो it will become half m a square omega square. So यहाँ से kinetic energy maximum आ गया आपके पास। अगर आपको न्यूमेरिकल में पूछा जाता है कि k max की वैल्यू निकालो, so it is simply half k square as well. So also potential energy की टर्म में भी half k square लिख सकते हो। So अगर आपको total energy नहीं given, तो आप either mean position पे, equilibrium position पे या extreme position पे आप energy की वैल्यू निकालो, that is your total energy of the system. So this animation I think clearly explains.
Sir, could you please show the last slide? Thank you, sir.
Excuse me, sir.
हाँ जी बेटे।
Sir, we are having next class now on 11:20.
And I think there are 3 minutes left.
Yes, sir.
So don't
So
worry.
please show last to last slide as well.
Last to last. This one?
Yeah.
Okay.
No, sir, not this one. Just the slide after this. Okay.
This one?
Maybe it was the previous one. Yes, sir, fine.